Okay, so then that's a generic overview of the extract, transform, load idea. Let's talk about some example flows. Now, these will go from simple to complex, and more complex questions are going to demand more complex tools. So, for example, potentially you could do an entire question with a single command, and we're going to look at that with the in the lab. Is we're going to try to write out a single chain of commands that will just do a relatively complex question and give us a result at the end of the day, which is pretty cool. But if you start needing to generate summaries, you might need to do something like pull your data into a spreadsheet so that you can manipulate it, or pull it into pandas so you can do additional work on it. Um, Especially, I will say for like forecasts, or trying to think about the future and how things in the past have changed and how they might continue changing. Well, then you're going to have to start using things like pivot tables and charts and maybe a little bit of statistical knowledge. You might want to pull in something like Tableau, which is a very good visual form of doing that. Pandas was based out of doing statistical analysis. So is the programming language R. These things become handier as the questions get more complex and more fiddly. They're not a prerequisite. You can do a lot of work with Excel, but if you the more complex it gets, the easier it is to use something that was built with that complexity in mind. Now, let's run through some examples. I have 3 here, and the first one's going to be a relatively simple one. Count the preservation files. I mentioned this earlier in the lecture. So you're at the end of a grant, and the grants and for the report, your boss says, I need to know how many files we generated so I can just put that into one of the sentences. It's not the most critical piece of information, but it's one that you get asked for all the time. Now, we'll say that all of the files from the project are in a single group of folders, grouped into subdirectories, and all the preservation files end with .mov. And you know that if a file has .mov at the end of its name, it is a preservation file. That was not used for any other kind of file. So how do we do this? Well, to extract, we list all the files in the subdirectories of that place. So ls-l path to project directory. And that will give us a big long list of all these files. Now to transform, we'll want to filter only for those files that end with .mov. So I'm going to pipe the output of that ls command over to the grep command, which is a global regular expression processing tool. And we'll talk about regular expressions during the lab, but it allows me to filter for lines that have .mov in them. And then I'm going to pipe the result of that command, and the result of that command is going to be a bunch of lines of text. Each of them have .mov. I'm going to count those lines of text, and counting those lines of text will say, hey, here's how many files that I was able to find that have .mov. It should be the total number of preservation files. So that was pretty direct. It was pretty fast. It's probably easier than doing that and clicking through folders and trying to make a count that way. It catches out all the edge cases, like what if one folder has 2 files, but another folder typically has only 1 MOV file, things like that. So it's relatively quick as long as you have that knowledge in the back of your head about how to generate that command. But let's go a little bit more complex. Total duration. This is another thing that people love to ask for. We paid to digitize a bunch of videos. How many hours of footage was that stuff? Well, again, we're going to use the same idea that they're all in a single folder and all of the preservation files end with MOV. Here, it's really important for you to filter for MOVs or for preservation files, because you don't want to say, well, you don't want to count both the duration of your service files and your preservation files. That would be doubling things unnecessarily. So we have the same setup. Let's extract. In this case, what we're going to do is we're going to use a tool called Media Info. And we're going to use Media Info to look we're going to tell it to look for specific fields. We're going to say, hey, give me the file name, give me the duration, give me a version of the duration, the third version of that duration, and give me the file size. You might not need the file size, but as long as we're generating this data, we'll grab it for now. I'm going to tell you to look at all files in the project directory that end with MOV. So that this command looks through and it looks at all the MOV files and it generates a report. It actually exports that as a CSV. And so we redirect the output to a file that we call project_techmd.csv. So this thing has the information that we need, but it doesn't have it summarized. It hasn't actually added together those durations. So the next thing that you should do is you should go over to Google Sheets or Excel or whatever your spreadsheet is, or you could do, and you could import that CSV in there. And then you look at these columns and you'll see that there is a duration column, and that duration column is a very neat, like 1 minute : 30 seconds, that kind of format of the data. And when you think about that, that's actually really, really, really hard to add together, which is why in this case, I have this duration/string3 version, which is how I tell media info to give me the milliseconds of every single file. So now instead of saying, 1:30, it says something along the lines of 90,000, which is, a minute 30 seconds is 90,000 milliseconds. Now, because it is just one number, I can just add up all of those milliseconds and then I can convert it to hours. I can divide by 1,000 to get into seconds, divide it by 60 to get into minutes, divide by 60 again to get into hours. And now I can say this is how many hours I've received. And then to load it, I would copy that value at the bottom of my column, however I did it, and I would give it to my boss and I'd say, great, here's how many hours of digitization work that we did with this. Now, I discussed this a little bit, but this is the first time that we're pulling into a spreadsheet. So let's talk about some of the problems of spreadsheets, which, as I said, are extremely helpful and sometimes too helpful. Now, the first thing is that sometimes you give something to a spreadsheet that looks like a number, and it's like, great, I'll treat this as a number, but really it's not a number. So something like a barcode. A barcode is made all of numbers, but it's really not a number in the way that we use most numbers. We don't add barcodes together. We don't multiply barcodes. We don't do mathy, numbery things with them. It's just an identifier. It's just a string of characters together that has a useful internal relationship to itself because of the number values, but like us who use barcodes to identify things don't care that it's actually made of numbers. That means nothing to us. However, a spreadsheet, if you import it, will load it and it'll be like, yeah, that's a number. And not only is it a number, it's a number so big that I actually have to transform it into something called a floating point integer, because computers actually do struggle with extremely large numbers. And something like a barcode will trip this up. And so when you load a spreadsheet with a bunch of barcodes in it and it transforms into something like, number dot a couple more numbers and then EE and another number after that, that's the spreadsheet representation of a floating point integer. You can look into this, but basically what it's doing is it's coming up with a number that's really close and easier for it to represent within its memory with the way that bits and bytes work. The problem is that it no longer has all the detail. So it doesn't look like the thing that you initially put in there. Another thing that happens that you might have noticed is something can look like a date. And then all of a sudden the spreadsheet's like, well, I know what dates are, so I'm going to convert this into something that looks like a date. So if you have like a rating scale in one of your columns, for instance, and you say in every single row, this is 1 out of 10, 4 out of 10, 2 out of 10, etc., there's a very good chance that your spreadsheet program, when you import that data, will then say, you know what that is? That's a month and that's a day. So 1 out of 10, January 10th. 4 out of 10, April 10th. And it will transform that data right in front of your eyes because it's trying to be helpful. And dates are hard to work with. So it's being like, hey, I got this for you. I'm going to change this into a date. whenever a spreadsheet is doing something along these lines, when it is taking a piece of information that you're giving it and then turning it into a different kind of information that it isn't really, the thing that will help you avoid that problem is when you import that data, especially from a CSV or an XML file or something like that. If you have the option to import as text or as characters, it will just look at 4/10 and it'll say, yep, that is 4/10. I will put that in there. That is the only thing that that is. I have no idea. I've been explicitly told not to think of this as anything but a bunch of characters. I will not try to transform this into something else. So that is one thing to be careful about with spreadsheets, and one way to get around that problem. Now, the other thing about spreadsheets, but this is sort of a general data problem, is that, as I mentioned with times, there's a lot of numbery things that we work with, but are hard to do numbery operations with. So for example, times are really hard to add up because as much as we can sit down and we can look at those two durations that I have here, 5 minutes, 7 seconds, 34 minutes, 56 seconds, and we can do the math and we can carry from the minutes column to the hours column and things like that. There aren't oftentimes easy ways to do that in a spreadsheet, or in whatever tool that you're using. Oftentimes it is very hard to combine things like this, and it might even start doing strange things like thinking of 5 minutes 7 seconds as like 5 minutes and 7 seconds past midnight, and how do you add 2 times of days together? So that can be hard. Something else that can often be difficult is file sizes. We love to report things in these like united numbers of 50 gigabytes or 20 megabytes or things like that. But then when you have to add 2 files together, and one's in gigabytes and the other's in terabytes, that gets to be a problem because, again, we can do this mentally, but with a computer, you have to start telling it, okay, well, that 1 terabyte, it's actually 1,000 gigabytes. So I need you to add those 2 things together, but also ignore the GB at the end because that's a unit. And so that's not part of it. I need you to just find the numbers and extract that and add that. And it gets to be its own like little programming challenge. So in both of these cases, it's easier if you just get the base unit of that data as part of your extraction process. So getting the milliseconds or getting the bytes or whatever numbery thing that you're working with, because then you don't have to transform out of this easy human readable format down to a easy math format and then back up again. You start with the easy math format, you do the work that you need to do, and then you export it to a human-friendly version. And that's generally a good approach to a lot of data analysis, is that the data that you extract might not be that human-friendly, but it's always good to have the most machine-friendly version. You can have a human-friendly version in the column next to it if it helps you work with that data. But when you're doing the manipulation, it's easier to have these more basic forms and then think about the human friendliness as the last step to be like, and this is how I help somebody else understand what the results of this report are. So going back to this thing, calculating the total duration, we can talk about thinking long term. So we have an in-house digitization program, and we're creating terabytes of files a year. And your boss is saying, that's a lot of stuff, and I need to start budgeting for storage. Like, I can't just pull out terabytes of storage costs at the drop of a hat. You got to tell me what you need for next year. So how do we do that? Well, first we can generate a CSV of all of the technical information from those files, and we can dump it in there. Then we can open up that CSV in a tool like Pandas or something like that. We can start grouping that data by year. We can start summing the total number of bytes, and we can start seeing like, okay, well, here is our project growth year over year. Are we in a steady state? Do we produce, 10 terabytes a year, or are we getting faster and more complex with what we're doing, and we're putting out more data every year? And we can start looking at trends. We could even create a chart of that data, and then we can push that forward and say, hey, here's how it's going, and I think actually we're going to be 2 terabytes more than last year, so I want to be able to have that much data. So lots of different ways that we can do this. And as I said, you're going to bring in different kinds of tools for different kinds of problems. I think it's very useful to think about all of these flows in a framework, because what has happened to me and what I see happen to colleagues is that once you can genericize your work, you can start applying it to other situations, and you can use, these small pieces that you've generated to answer one question in order to answer different kinds of questions. And these happen all over an organization. They can happen in acquisition, description, storage management, usage, accessibility. They can go from things for like, I need a number because my boss wants a number, to I need caption files for 10,000 videos because we're getting serious about providing accessibility to our media, and we just need to generate 10,000 caption files at this point in time. So I need to at least generate that base set so that we can get started working on getting good captions up. And, oftentimes this is, I will say from my experience, something that organizations have a hard time thinking about, like, where do these kind of skills fit within an organization? Even if you have, a software development department that you work with, oftentimes they'll be working on big programs and big problems and trying to build out software for you. And this sort of small, I have data here and it needs to be in a slightly different format, and this might be the last time I ever do this program or this project, is not something that really gets filled by any specific role in an organization. So it's a place where if you like doing this kind of thing, you will find pretty broad applicability, and you will find ways to, work with other people within your organization, or you could find ways to transition into different kinds of careers or different types of topics within your career, because, hey, maybe it turns out you don't like doing processing of archival collections, but you sure do like doing analysis of usage and proving how how well people are able to use your access platform. Well, same types of skills apply in terms of being able to extract information, transforming it, and then creating a report that presents that information in a useful way. So the final thing, just to wrap up the key points, is that you have to think about this in a sort of framework that, you got to figure out, where am I going to get the information to answer my question? How am I going to extract it? How am I going to transform it to get to my final result? And then how am I going to get that result in front or into a system that needs it, or in front of a person that needs it for a decision or to get a report or something? Secondly, there is no single tool that does this. All of these things are typically cobbled together, and you will use a variety of skill sets to pull it together. So it's another place where talking with colleagues and building skills and thinking more broadly as you work on a project and saying, okay, I added this to my skill set, or I can see that this might be a thing that I need to work on a little bit more in the future, is a really, really good thing to do. And then finally, spreadsheets, really, really fantastic, really good intro into this kind of work. They do have some pitfalls, and so especially if you're working with dates, barcodes, really big numbers, be careful about how you're using it, because it might introduce errors into your process. All right, well, that's it for this week. For the lab this week, we're going to be talking about doing some transformations and doing some slightly complex versions of the things I went over in the lecture.